what's up to you guys? For today's video, we will be solving a bolted connection under eccentric loading. No, this topic is under PSAD po, and we have our problem from the figure shown. The bolt diameter is 22 millimeters. Determine the following: the shear stress due to load alone. Second, shear stress due to moment. Third, most critical rivet, and lastly, the maximum shear stress. So we have our figure here. We have our load. No, so this load is 160. Okay, it should be 160. 160 kilonewton. Sorry for that. Okay, so we have our load, no, 160 kilonewton applied 300 millimeters from the centroid, no, of the bolted connection. Next, we have the spacing of our bolts vertically. That's 100 millimeters center to center, and horizontally 180 millimeters center to center. Okay, so we can now jump to our solution for the first part. Okay, the required is the shear stress due to load alone derived from the strength of materials. Shear stress tau is equals to the shear force divided by the area parallel to the shear force. Okay, so in steel design, no, we will be using the parameters FV. So this represents the shear stress is equals to P direct. It is the load experienced, no, by single bolt, and then divided by the area. In where P direct is P total divided by the number of bolts. Okay, so we can now substitute values. FV is equals to 160 times 10 cube divided by 6 pieces, so and then divided by the area, pi over 4 times 22 squared. Okay, so our answer here is 70.15 MPa. Okay, so this will be our answer for question number 1. Boom. So let's see. Next, required is the shear stress due to moment. Okay, so we have our formula, no. Shear stress due to torsion. That's shear stress times moment times the rho over J. Okay, this is the torsional. This is the polar moment of inertia, the radius, no? And this one is the moment. Okay, so moment, we can solve for moment. That's M equals to P times T, in which we can solve for this one. We have component here, no, sorry, this one. We have here this component, x component, or the horizontal. Next is the vertical component of the force. So this one, that's 3/5, no, 3/5 of 160. That's 96. Okay, this should be 96 kilonewton, and this one 4/5 of 160 is 128 kilonewton. Okay, so this component, no, will cause torsional moment or moment from the member. Okay, so this 96 will cause a clockwise rotation like that, and this 128 will cause a counterclockwise. So in order to get the resulting moment, we should add, no, the moments where 96 kilonewton times 300 mm or 0.3 meters. Then since they have the opposite direction, that's minus 128 times 0.2. Okay, so our resulting moment is 3.2. That's 3.2 kilonewton meters, no, in that direction. That's a clockwise direction. Our rho here, okay, from the center of gravity, this will be our rho. Okay, so this is our x, and this will be our y. Okay, so we have the y, no, that's 100. We have our x, this will be 90. So our rho here is 100 squared plus 90 squared. That's square root of 18,100. Okay, so that's 18,100, and we have J. J is the polar moment of inertia. That's IO. Oh, sorry. That's IX, no? IX plus IY, in which IX is I sub O plus the transfer formula. Now we are going to transfer each bolt to the centroid, no, or to the center of gravity. So that's AX squared plus I sub O, so this one, plus A y squared. Okay. Okay. So we can since this is a transfer formula, this will be negligible now due to smaller value. So what we have left here is ax squared plus ay squared. And since there are a numerous number no of bolts here that we will be going to transfer, so that will be the area of each bolt times the summation no of x squared plus y squared. Okay. So this will be our j. So we can solve for area, check, and summation of x squared plus y squared, that will be that can be calculated as squared plus x squared plus y squared. It will be that this is 90 mm, no? So that's 90 squared for x, no? 90 squared times there are 6 bolts that has 90 or distance of 90, so that's times 6 plus y, that's 100 squared times there are 4 rivets that has a 100 distance. Okay, so that's times 4. So we have our value for summation of x squared plus y squared, 88,000. So that's 88,600 millimeter squared. Okay, so we can now solve our torsional shear. So this will be uh, say Fv due to torsion. Okay, equals to moment. Our moment is 3.2 kilonewton per meter. Okay, so let's just convert it to Newton millimeter now. So that's 3.2 times 10 to the 6 times the rho square root of 18,100. Okay, we have our area pi over 4 22 squared times 88,600. Okay, so this will be our summation of x squared plus y squared now. So our answer here will be that's 12.78 MPa. Okay, so this will be our shear stress due to torsion. Okay, so for our question number 3, no, the most critical rivet, which is somehow related to the maximum shear stress. Uh, okay, let's remove this one. So it asks for the maximum shear stress in which it occurs on the most critical rivet. So we will analyze, no, in which rivet uh, it is where shear stress is maximum or it is most critical. So say this is our center of gravity. No, due to the direct load 96 and 128, these 6 bolts will have a reaction, no, like this one, opposite. Okay, that will be their reaction to the right. Okay, okay, and due to torsion, these 6 bolts, or should I say, okay, these 6 bolts will resist, no. So if this is our moment arm or this is our rho, okay, so I assume that the critical or the maximum torsional moment, no, occurs on the farthest bolt, in which it uh, disregards the rivet 2 and 5 since they are close enough to the center of gravity. Okay, so I consider 1, 3, 4, and 6. Okay, so the reaction, no, due to torsion, since our rho, or sorry, our moment, our resulting moment is 3.2 kilonewton meter in a clockwise direction, like this one. So this 4 will, or this 6 bolts will resist, no, in a will resist, okay, which will be perpendicular to its moment arm from the center of gravity. So the resisting load or load reaction of the bolt, no, due to torsion will be like this. That's it. So this is perpendicular to the moment arm, no, from the center, and this, okay, and this one. Okay, so from the figure, no, bolt 1, uh, the component of the torsional load will be subtracted to the p direct. So it cannot be the maximum, and so as to the third. Okay, so from the fourth, the horizontal or the vertical load is maximum, but the horizontal is will be subtracted, so it cannot be. So the most critical rivet is 6 because the component of the torsion will go to the right, no, and this will have an upward component. So if we add uh, both x and y components are maximum. Okay, so for most critical rivet, it is rivet number 6, right? Okay, so let us compute the maximum shear stress of bolt number 6 now. Okay, we can use the FD total, no? That's FV, so that's number 4, total will be equals to the R divided by the area of the ball, where R no is the summation, R is the square root of the load no due to direct shear PDX no along X plus P along due to torsion PTX squared plus PDY plus PTY squared. Okay, so this is due to direct shear PDX and PDY, and PTX is due to torsion as well as the PTY, in which PDX is that's 128 divided by 6. PDY is 96 divided by 6. Okay, so we have values for this 21.3 kilonewton and 16 kilonewton. Okay, so we have PTX no. PTX is, we can use FV no. This computed from number 2, 12.78. So that's 12.78 times the area of the ball, pi over 4 times 22 squared. Multiply it no, the component. So uh that's 90 over square root of 18,100. All right. So our value here, so this will be 32. Sorry, that's 3.25 kilonewton, and PTY will be 12.78 times pi over 4, which is pi, times 22 squared times 100 over square root of 18,100. So this will be 30, that's 3.6 kilonewton. Okay, so we can solve for R by substituting these values. No, okay. Okay, so our calculated value here is 31.44 kilonewton. Right? So that's our critical reaction. No? So if we are going to substitute that, no, so that's FB total. It is 31.44 times 10 cube over area, pi over 4 times 22 squared. So FB total will yield to 82.70 MPa. So this will be our maximum shear stress now, which will occur on rivet number 6. Our solution for this problem.